All right, this is 1.1, and it is on Algebra Essentials. Okay, don't forget, we are a device-free zone. No phones, no computers. If you have a computer open, that's fine. I mean, it's not a big deal. Okay, Algebra Essentials. So what we're looking at today is we're going to be talking about order of operations and real number properties. And someone asked you what real number properties, we're talking about like the commutative property, the associative property, the distributive property, identities, and inverses, which you probably have talked about before, hopefully. If not, you'll learn something new today. And we're going to use those to be able to evaluate and simplify expressions and equations. Okay? This is literally almost the exact same lesson I taught to Algebra 2 today. Okay? So that should give you a little bit of, don't stress out. Other than the properties, I didn't teach them properties. Okay, why is my first slide empty? Oh, it's not. Essential question. That's what our essential question is. You don't have to write this down. How can we use order of operations and real number properties to be able to evaluate and simplify an expression? That's what the goal of today is. Okay? So, this is not your lesson. Oh, no. It is. I told you, it confused me because this is what algebra uses. So a numerical expression is an expression that is made up of a number, operations, and a grouping symbol. In a numerical expression, there are no variables. No variables in a numerical expression. So like this is going to be like 2 plus 5, or 5 times 3 minus 1. Those would be numerical expressions. Who can tell me the biggest difference between an expression and an equation?
The equal sign.
An equal sign. So expressions do not have equal signs. Equations do. Okay? So in that top one, 2 plus 5, if I wanted to make it an equation, I would have 2 plus 5 equals 7. That's the book.
Oh, boy, howdy.
Yeah. If you printed it out, that's how big it is.
Oh, no.
Wait, that's for just us?
It's just your bag. Yes. Okay. So, we're going to talk about classifying real numbers. So, there are a real number. Okay, we have two types of numbers, real numbers and imaginary numbers. Okay, real numbers are just like normal numbers we use every day. The imaginary ones are the ones we put the eyes on. Did you do those in Algebra 2 last year?
Yes,
Yeah.
ma'am.
Okay, so most of what we do is in real numbers. Okay, so when we really say like classifying a real number, we're just like classifying numbers, basically. Okay? So we have what we call the natural numbers. Basically, those are your counting numbers. It's where you start at 1, and you go 1, 2, 3. We do a lot with set notation in here, so if I were to put this in set notation, I would put the little squigglies. My squigglies always look like garbage. 1, 2, 3, and then you put the dot, 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 so it goes on forever, and then you close your bracket. Okay? So the natural numbers are 1 to infinity and beyond. Whole numbers are the natural numbers, but this time we add 0. So the only difference between the whole numbers and the natural numbers is that 0 is involved. So here you have 0, 1, 2, 3, and so on.
Wait, why do you put the brackets on again?
Why do I put what? The brackets, that's set notation. So if it asks you to write it in a set.
Okay.
It's just saying like that's a set of numbers. Okay. So like we'll talk about like domain and range and stuff on graphs. And so usually when we talk about domain and range, you talk about it being a set of numbers, so we put it in set notation. So I'm just getting you involved. Plus the book talks about it. Integers. Integers are the whole numbers, but now we're going to add the negatives. Okay? So this time we go -3, -2, -1, 0, 1, 2, 3, and beyond. So again, you have your brackets, and it's basically what I just wrote. This time we're just going to put it with a bracket. What? Yeah. I feel like the reason like I'm so hot is I think the vents are right there where you guys are. So I'm like burning up, and you guys are like, it's so cold in here. I'm like dying of a heat stroke.
Is like 85,000
Degrees over there. Yeah, and so then come out here, there's like actually. Okay. Any questions on natural numbers, whole numbers, and an integer? So if I give you the number 5, 5 is a natural number, but it's also a whole number and it's also an integer. Does that make sense? Okay. But if I give you 0, 0 would be a whole number, but it's not a natural number. Does that make sense? Okay. If I give you -2, that would be an integer, but it wouldn't be a whole number or a natural number. Okay? Rational numbers. We talk about rational numbers. We'll talk about rational, like rational expressions, rational things. Rational just means it's a fraction. So we've added the fractions in. So it might be -2, 1/2, or -1/2, -1, 0, 1, 1/3, 1/2, 2. So you're taking the integers and now we're adding in the fractions that go in the middle there. Okay? So a rational number is any number that you can write as a fraction. So they say like m over n. The only thing you have to worry about is if n can't be what? What can't n be? 0. Why can't n be 0? Because you can't divide by 0. You know those math shirts that everyone has, that the department has, that say like, I don't know. I don't have one because I wasn't here, but it says like something about dividing by 0. Someone divides by 0. So all fun and games, someone divides by 0. Cannot divide by 0. So rational numbers are anything in the form of m over n, where n cannot be 0. Okay? You can also write a rational number as a decimal, right? 1/2 can be written as 0.5, right? So rational numbers are decimals in two different forms. They are either terminating decimals, so that means they have a stopping point. So the example the book gives is like 15 over 8. If you put that in a decimal form, it's like 1.875. Okay? That is a decimal that terminates. It doesn't keep going on forever and ever and ever. That's a stopping point. Rational numbers also are decimals that have a repeating part. Okay, so like 1/3 is 0.33333, and it just keeps going on. Your calculator will put like a 4 or 6 or something at the end of it because it ends up rounding it eventually. But it really just repeats on forever. Okay? Or like another one they give is 4 over 16, or 4 over 11, I'm sorry. And that as a decimal is 0.363636. So that 36 repeats every time. So we'll write that as 0.36 with a bar above it. You guys remember seeing that?
Yes.
It's been a long time since I've done repeating decimals, so. Okay, so rational numbers are anything that can be written as a fraction, or if it's a decimal, it has to be terminating or repeating. Okay, pi, the number pi, what is pi, like what's the decimal version of pi? Anyone know? Wow, girl, you got a lot more digits than me. 3.14159.265. I don't know the rest of it, but none of those numbers repeat. So when we talk about pi being 3.14159, blah blah blah, it's not a sequence of numbers that keep repeating. Does that make sense? So this pi cannot be written as a fraction. It does not terminate because it goes on forever. It does not repeat, so that's why it's rational. So the book says any number that's not rational is irrational. Okay? So if you're checking to see if a number is rational or irrational, if it does not terminate or does not have a repeating decimal, then it has to be an irrational number. Does that make sense to you guys? So when you are checking, because you will have problems on your homework today that ask you to say whether it's rational or irrational. If it's not rational, then it falls in the irrational column. So if it doesn't fit into any of these categories, then it has to fit into this. Okay? Does that make sense? So it's easier just to say that, like, irrational numbers are anything that's left, instead of me saying, okay, well, here's all the things we could check for. Okay? A lot of the square roots are irrational numbers. Like the square root of 11 is an irrational number. Because when you find the decimal of it, it's just like a lot of random numbers. There's no pattern to it. Okay? Anybody have any questions on classifying a number?
So imaginary numbers are just 50.
Yeah, so it's almost like, okay, I really wish this board wasn't so low. Okay, it's really like if this was the world of numbers, okay, you have two categories, real versus imaginary. And in the real, we have everything we just talked about. The whole numbers, the integers, the natural numbers, the rationals, and the irrationals. That all fits in the real number area. Okay, does that make sense? Any questions? Okay, so this is the picture they had in your book, and you don't have to draw this in. Oh my
It's in the book.
iPad just shut off. Yeah, reconnect.
Where?
I believe it's on page 10, but I could be wrong. I'll look it up in a second.
It is page. No.
They said in the textbook, Rose.
Yeah, it's in your textbook. No, it's the guided notes. It's in your textbook.
Then everybody was looking too.
Yeah, it's on page 5 in your textbook. Page 5 of your textbook.
Oh.
Not in that thing. That's your guided notes. That is not a textbook.
Your
Your textbook is that one on your laptop. You will not get physical versions of the book
Would it be helpful if I
unless you want to print off all 500. Oh, I'm sorry, 700 and mine stops at like 800 and something. 833.
Are we doing this whole book?
Okay. So we have some examples. It says the first set say write each of these as a rational number. So for it to be a rational number, it has to be written as something over something else. It has to be written kind of as a fraction. So how can you write 7 as a fraction? 7 over 1. Oops. How do you write 0 as a fraction?
So rationals is fraction?
Yes, rationals are just fractions. 0 over 1. Negative 8 over 1. Alright? So you can write any number. So that means that's how you make the counting numbers part of the rational numbers. Does that make sense? Put them over 1. Okay, so it says write each of these as either a terminating or a repeating decimal. So what's, anyone have a calculator? Get a calculator out. Anybody? Anybody? They probably need these calculators.
Do we need a
guys
graphing
can't get
calculator?
unless you check them out for me.
Do we need a graphing calculator? For the final activity.
5 divided by 7. Okay. I'm so sorry. Okay, so mine says 0.7 71428 5, and then it starts repeating again. And it says 7 1 whatever. So then you put a bar above it. 15 over 5. What is 15 over 5? 3. So if I put it as a decimal, it's 3.0. Because that would be a decimal. We don't usually write it as 3.0. 13 over 25 is 0.04. So just really want you to write these as decimals. Pretty dumb. You know what's really annoying? I already don't like this book. Because there's like 50 examples. I'm not kidding you. And half of the examples have nothing to do with what the homework was. So I had to go through the homework and figure out what I gotta go over to match up. It's really annoying. Okay. So it says determine whether each of these is rational or irrational. Square root of 25. What is the square root of 25? 5. Is that a rational number or is it irrational? It's rational because it's actually a integer or a whole number or a natural number, and that all fits into the rationals. Okay. 33 over 9. What does that reduce to? 11 over 3. 11 over 3 is a decimal is 3.66666 going on forever and ever. Oops. No bar. Your calculator eventually rounds it off to a 7, but that's because it keeps repeating. So this is a repeating decimal. What kind of number is it? It's a rational. Rationals have repeating decimals. If it doesn't repeat, or if it doesn't, oh wait, I'm sorry. It's got to be repeating, or this one repeats because it's 0.6666666. I added the 7 because that's when my calculator rounds it off to eventually. Okay, last one. Square root of 11. Well, if you type in the square root of 11 into your calculator, it gives you 3.31662479. Is there anything there that repeats? No. It's not really terminating either because it's just going to just keep going in your calculator. Your calculator just doesn't have enough space to keep writing it. So this would be an irrational number. Okay, does anyone have questions on how to determine if it's rational or irrational? No. Excellent. 7 of 16. We're almost there. Anyone still writing? I'm sorry. 7 of 16 sides.
7 over.
Now we're on 8 of 16. We're halfway there. The last side's your homework, so really we're over halfway there. Okay. Order of operations. So in order of operations, how do you remember that? Please excuse my dear Aunt Sally. What's the P stand for? Parentheses. So in algebra 2 or algebra 1 or geometry, parentheses is usually where we end that. In college algebra, they make your problems harder. So you're not just going to be a set of parentheses. It might be brackets. Or it might be absolute value bars. Or it might be, really the parentheses stands for grouping symbols. So anything that groups numbers together, you take care of that first. So if it's a parentheses or a bracket or even absolute value bars, you take care of that first. Okay? The E stands for exponents. Okay? Pretty self-explanatory. 2 squared, you take care of that next. Multiplication and division are next, right? Multiply, divide. Okay, and then what did the A and the S stand for? Add and subtract. Good job. Okay? You know those things on Facebook you see all the time? Well, I don't know if you see them all the time.
No one can get this right.
Yeah, it's like comment with your answer below, and you look at the comments. There's like 100 different answers. Because those people do not know order of operations. Because usually in the problem somewhere it'll be like 12 divided by 2 times 3. And what do people most of the time do?
Just do it in order.
Left to right.
Well, that's what you should do. Most of the time, people do 2 times 3 because multiplication comes before the D. Multiplication and division are together as one. So a lot of times I'll write the P and the E, and then I'll do the M and the D as one step, and then the A and the S as another one. Almost like you're doing like hopscotch or something, if you think of it like that. Because the M and the D are really one step. You do whatever comes first from left to right. So what would I do first? The 12, you would divide first. So the 12 divided by 2 is 6, and then 6 times 3 is 18. But yeah, so if you do the 2 times 3 first, and you got 6, then you would do 12 divided by 6, and you would get 2, and that's a completely different answer. And that's why a bunch of people have the wrong answers on those Facebook thingies. Okay? Why did I do what? Why did I do this first? Because these are one step together. So you do multiplication and division together as one step. So whatever comes first, when you're going from left to right, you take care of that first. So since the division came first as I went from left to right, I took care of that and then I multiplied, even though the M comes first. Any questions? Okay, so there's a problem at the bottom there. And I'm actually going to insert a new slide. Minus what?
Minus 4 to the second power.
Thank you. Uh-oh. What is it? 24 minus what?
It's 24 plus 6
Times 2/3.
minus 4 to the second.
Equal.
So we need to simplify this. Okay, this is an expression, a numerical expression that we need to simplify down. So what do I do first? The exponent. So you get 24 plus 6 times 2/3 minus 16. Right? Then what do I do?
Multiply.
Multiply. So I take care of this 6 times 2/3. When you multiply fractions, you multiply across, multiply bottom. So across would be 12 over 3. And what's 12 over 3 reduced to? I'm sorry. What's wrong? Did I do something wrong?
Wait, that should be on 16, right?
This is so the minus was like you're doing 4 squared. If it wanted to do negative 4 squared, it would put the negative in parentheses with it. That's a really good question. So his question was, shouldn't that be a plus 16? Because he said you took negative 4 squared. If it wants you to do negative 4 squared, it'll put the negative with the 4. Well, the 2 will be on the outside. But it'll put it like that. That would be 16, because that would be negative 4 times negative 4. But this is really negative 1 times 4 squared. We just put, like, we don't write it like that. We just write minus 4 squared. So it's minus whatever 4 squared is, which is 16. Does that make sense? That's a good question. Okay. So does everyone understand how I got 4 when I took 6 times 2/3?
Yes.
Okay. So then 24 plus 4 is 28. And 28 minus 16 is 12. Fun fact about me. I can do a lot of math. Okay? I have a master's in math. You can do some upper level math here, but I am terrible at basic addition and subtraction. So, like 28 minus 16, probably would take me a lot longer than you guys. So, if I write something up here and it is wrong, please tell me, because I probably did some addition wrong.
I give you a hard time.
Go ahead.
What's 16 plus 7?
16 plus 7? 23? Is that right?
Yeah. I just wanted to
Okay. Any questions?
Honestly, same. I'm just like lost.
Yeah. Yeah. It's like once you get to like some upper level math and you stop worrying about like how to add. Because you got a calculator. You know, when I was in school, they used to be like, you're never going to have a calculator all the time.
Yeah, I do. I got a
Look at me
phone.
now.
I promise you.
Okay.
And they were like,
Y'all be like,
Well, let's do the first one.
Oh my god.
There's a bunch of these, and I don't want to waste a bunch of our time, but I want to make sure we know how to do them. So let's skip A and let's go to B. Just because A is, I know, I'm really sorry, but A is a little bit easier, so we're going to skip over A. We're going to go to B. So on B, a square root is also a grouping symbol, so take care of the grouping symbols. Okay? Fraction bars are grouping symbols. So when you do fraction bars, you're really going to take care of the top part, and then you'll end up dividing it. Does that make sense? So let's take care of our square root first. So we're going to have 5 squared. Oops, I'm sorry, it transferred me over to the box one. So we have 5 squared minus 4 over 7 minus the square root of 9, which is 3. So 5 squared minus 4 over 7 minus 3. If you wanted to, you guys are pretty smart kids. You could have skipped steps. Like you could have put 25 minus 4. Just make sure that while you're skipping steps, you're not skipping too many steps. Okay? I don't want to skip steps because I don't want someone being like, how did you get there? I don't know where we got that. Okay? So now I'm going to stop worrying about that 3 and I'm going to take care of the top part of this. So that's going to give me 25 minus 4, because 5 squared is 25. And what's 25 minus 4?
21.
21.
oh my goodness.
So worst day of my life was when that stupid Vine video came out. It was forever after that. Every time we used
That
the word 21
number.
or number 21.
3 minus 2.
Word.
Oh my god,
Horrible.
0.
What's 21 minus 7 or divided by 7?
3.
And what's 3 minus 3?
0.
Now, see how we did like the square root here, or we did the 25, and then we subtracted the 4, and we did that before we divided by the 7? That's because this is like a grouping symbol up here. Really, that's in a set of parentheses. So you have to take care of everything on top before you divide. Yes.
So would the bracket things, like, would those ever be in equations, or is it just like a group of numbers? At the beginning of class, like when you were writing the bracket thing?
The brackets will be in like these long things, but they probably won't be in a lot of
Would
them.
it count as like
Yes.
Okay.
Brackets count as a set of parentheses.
like
And
any bracket?
there will be one, here in a minute.
Okay.
Okay, in part C, see how we have a set of absolute value bars? That is a grouping symbol. So you have to take care of those first too. Okay? So in that bottom one, we take 6 minus 5 minus 8 is -3, and then absolute value makes that 3. So it's going to be 6 minus 3. You might say, well, the 3 came out positive. Well, it did, but we still had that negative we had to bring down. Okay, does everyone understand how I got that?
Yes.
Okay, so then I'm going to go plus 4, or 3, I'm sorry, plus 3. And then I'm going to do the parentheses here. What's 4 minus 1? 3. Okay, so I took care of both grouping symbols right away. Is everyone cool with what I did there?
Yes.
Does anyone have questions on how I got there? Albert, you good?
Yeah, I got the answer.
Wait, I'm sorry.
Answer's 12.
Oh.
So, we not distribute the 3 to 4 and
I got it first.
You can, if there was like an X in there, I would distribute. Because it's just 4 minus 1, I would just take care of that. Because if you distribute it, then it's going to give you 12 minus 3, which is going to give you 9, which is the same thing we're going to get when I take 3 times 3 here in a second.
So,
So it'll still give you the same answer, yes. Yeah, so it's not stupid to do that. Like, you're like, it's not stupid to do that. You're fine. If it was a variable, I would distribute it in. But because it's just 4 minus 1, I would rather do 4 minus 1 and then multiply by 3 than distribute it in. Did everyone hear Malia's question?
No.
So her question was, can I take this 3 and distribute it in and get 12 minus 3? Oops, I already wrote that over here. Okay? And then what you're doing, you're taking care of that entire problem right there. So where she's going to get 9 there, we're going to get 9 eventually. Okay? So it's going to work out either way. I told her if it was a variable inside that, like if I said 4x minus 1, I would distribute.
Would that be longer?
It's not longer. I mean, you're taking care of the 3 R off the bat. You're just multiplying to both of them. I like smaller numbers, so I would rather subtract and then multiply than have to do bigger numbers. Yes. Okay. So now I'm going to multiply. So I get 6 minus 3 plus 9. Because 3 times 3 is 9, right? And then we do subtraction and addition on the same step. So 6 minus 3 is 3, and then 3 plus 9 is 12. Any questions on that? Okay. Are you guys tired of doing order of operations? Okay. It says with your table partner, why don't we just skip to this one? Because this one's kind of got a lot of stuff going on. Is that cool? So why don't you with your table partner discuss how to do that problem? I'm going to give you a couple minutes, and then we will talk about it.
Yeah, the brackets are doing.
Okay, they brought me these TI-30XS's, and I believe that they are working on getting me graphing calculators at some point. These calculators you have to check out using your ID badge. So it's like a collateral system. You guys know how collateral works?
Yes.
So you give me your ID, I give you a calculator, and then when you give me my calculator back, I give you your stuff back.
Wait, so I can't get into the building until I give you the calculator back?
Yeah, so you give me my calculator back. Mr. Farley said that calculators were going missing, so we have to create a checkout system. So that's the checkout system. Yes. Okay. I know that we have some, but I don't think that we don't give them out on test days, and I do believe that when you go to like KU to your final, you can't take our calculators.
Yeah.
You're
So,
I think there's like someone like Facebook.
yeah, that are cheap. That's where I would look. That's a really great idea. Hey, Jaden asked about graphing calculators, and I do believe you have to buy a graphing calculator. Okay. Now she said they're really expensive, and we do have some here. You cannot take them home with you. So I have not been given them yet, but they are not ones that you can check out to take home. You can use them while you're in the room. But that also applies like when you go to KU to take your final and that kind of stuff. She suggested, she was like, Facebook Marketplace has them, and I've seen them all over Facebook Marketplace a lot. I have a couple calculators that I would be willing to let you borrow as long as you bring them back. But they are mine. I have invested my monies in them, so I would appreciate you nudging it. Miles, put his hand up first, and I'll come to you now. Tyler. What? Oh, yeah.
So the hard bracket is just something, but is it like a double parentheses where you?
Yeah.
Yeah. Okay.
So you take care of this, like this, and the rest, and then do the thing. Does that make sense?
Yeah. So I gotta distribute. So what you gonna do? So the hard bracket is just another parentheses around. So then that two, I do everything inside and then distribute. But at the same time, I do 7 times 15, which is 105 minus 2. I'd be like,
I got it right.
I got 13.
You should end up getting 132. Wait, when you finish it. But that's just a check for you. I'm gonna give you a little bit more time. I can keep touching my screen though because if it let it time out, we gotta reconnect and really make it annoying.
That's 16, right?
Get it? Hey.
So this is gonna turn into an addition sign. So this would be
Take care of that.
negative.
Negative.
So now would I distribute, or would I distribute also?
But it's not what you're trying to do.
Actually, I think
Next to it, so that's negative 2 times negative 13. Does that make sense? No, you didn't, right?
You said 132, right?
132.
Yo, times the 132.
Yeah, well, there's this Oswald.
Up front, over by, Nick.
Oh,
Oh,
I had to move it because of the way the trash can.
oh,
to make negative 13.
right.
And then you kind of times those ones that's the multiplication first.
Oh, he cut.
Negative 6.
I put my rib out of place so long ago. I've been ignoring it.
Okay. Alright, let's talk about this. 132 is what you should get. Okay, let's talk about it. What should we take care of first? Those brackets. So inside the brackets, we take care of the 6 minus 3, which is going to give me 3, and then minus 16, right? So that's plus 1. That negative 2 is being multiplied there, so don't, forget that part. 7 times 5 minus 3. Okay. So then we do the 3 minus the 16. So 7. I'm also going to do the 15 here too. Minus 2 times negative 13 plus 1. So then I go and I do my multiplication. So 7 times 15 is at 105. Is that what I saw on your piece of paper? And then negative 2 times negative 13 is going to be a positive 26 plus 1. And then if you add all that up, that gives you 132. Okay? Any questions? Now that is the bulk of your homework is order of operation problem. That's the big bulk of it. Okay? Do you have a question, Chris? You just stretch it. Okay. All right. Properties. We're going to go through these pretty quickly because there's not a lot on properties, but it's important that we know them. Properties really happen mostly in addition and multiplication. Division and subtraction don't have a lot of properties. Okay? So commutative property. Can anyone tell me what the commutative property means? Or what it tells us? It means that the order doesn't matter. Order doesn't. Oops, I must have gone to the calligraphy matter. I feel like Harry Potter over here. Commutative, yeah, commutative. So that means if I take A plus B, that's the same thing as B plus A. So 2 plus 3 is the same thing as 3 plus 2, right? Or if I take A times B, that's the same thing as B times A. So 2 times 3 is the same thing as 3 times 2. Again, this does not work with addition and subtraction and division because 5 minus 2 is not the same thing as 2 minus 5, right? 5 minus 2 is 3, 2 minus 5 is negative 3. Same thing for division. If I take 10 divided by 5, that's 2, but 5 divided by 10 is a half. So commutative only works for multiplication and addition. The associative property means that grouping symbols kind of don't matter. So it's like if I take A plus B and then I add C, that's the same thing as if I take A and then I add B plus C together. Does that make sense? Okay? And multiplication is the same thing. If I multiply A times B and then multiply it times C, that's going to be the same thing as if I take A and then multiply it by the product of B and C.
So how would you put that into words?
Good question. That grouping doesn't matter. Okay. Grouping does not matter. But again, only for addition and multiplication. Okay, subtraction and division don't fit into that. The distributive property. You guys know the distributive property. Says if I have something outside, that's the same thing as saying, like if I have A times B plus C, that's the same thing as saying A times B plus A times C. Okay? That's the distributive property. And I wouldn't write that out in words because the way they word it is super weird. Okay? But you guys know how to distribute. That's like something you guys learned in like 4th grade. I have no idea what you learned. Identity. The identity says that if you add something to it or multiply it by something, you should get that same thing back. So we're looking for the same thing. So if I add two numbers and I want the same number when I add them, what's the identity? What's the additive identity? So what plus a number gives me that number back? So what can I add to 2 to get 2? 0. So the additive identity is 0. Okay? Because 2 plus 0 is 2. 3 plus 0 is 3. Okay? What can I multiply a number by to get it back out? So what? 1. So the multiplying identity is 1. Because 2 times 1 is 2. Or 3 times 1 is 3. Okay, an inverse is when I want to get, for adding, it's when I want to get 1. So, hang on, stop. Adding is when I want to get 0. So for the inverse for addition, I'm looking for a number that gives me 0. So what two numbers add to 0? Like if I give you 2, what plus 2 gives me 0? Negative 2. What plus 3 gives me 0? Negative 3. So for addition, it's the opposite number. Right. Whatever gives me 0. For addition. For multiplication, I want 1. So if I want to multiply 1/3 by something, what times 1/3 will give me 1? 3 over 1. And what times 2/3 will give me 1? 3 over 2. So what am I doing there? I'm reversing it. So what's that called? It's reciprocal. So the multiplication inverse is the reciprocal. I don't know if this is even showing up on yours. That's like really decently written. I'm really sorry.
It's all over.
We're about to run out of time, which is not going to be good.
So the whole
We're already so far behind. So I don't know what we're going to do.
It's because we're behind.
Really, the rest of it is not hard. It's like simplifying expressions, so combining like terms and solving equations.
I know how to combine my
You do know how to do
What if
that.
I'm breaking my right hand?
I think we're good. We're done.
Okay. Yes. It will be. Simplifying expressions just means to combine like terms. I know this is really hard for you to see. So combining like terms. So in that first problem that says 3x minus 2y plus x minus 3y minus 7. What combines? The x's. So how many x's do I have? 4x. Negative 2y minus 3y is negative 5y and then minus 7. Okay? They get a little more complicated here, but just remember that you have to distribute that negative first and then combine them. Okay? I'm going to go ahead and get past that because I know you guys are good to go on that. And if you get to the homework and you have questions, we will have time on Monday. This was just a really long lesson. They throw a lot of stuff in this. And we were supposed to do it 2 days. So. Oh, wait. Is that it?
Oh, we done?
Can we do C real quick?
Yeah. We can still see. So C is 4t minus 5 fourths s. I'm going to go ahead and distribute my negative. So minus 2/3 t plus 2s. So 4t minus 2/3. I need to get the 4 so that it's in a third. So what can I multiply? So it'd be 12/3. So 12 over 3 t minus 2 over 3t is going to give me 10 over 3t. And then you would change that into fourths too. Okay? Are you guys ready for your homework? I didn't do any solving equations, but I know that you can solve an equation. Okay? And if you have problems with it, we'll look at it on Monday. So your homework is page 15. You're going to do 1 through 3, 5 through 51 odd.
I'll take a picture of this.
Yeah, and I'll put it on classroom.
Oh, it's on classroom.
What?
Do you take these on Thursday?
I will take them on Tuesday. So normally if I give you an assignment on Friday, it's due on Monday. Normally on Friday assignments due Monday. But I'm going to give you till Tuesday to do it. So come, try to look at it over the weekend. And I would really focus on the 53 through 68. They're not hard, but they're word problems. Okay, that kind of goes over what we did. So that's what I would focus my attention on because I think you can do the rest of them. What? Yes. Yes. I don't have the homework log sheets right now.
But will we?
We will have them on Tuesday, yes.
Okay, do.
Okay? I mean, I can give you one right now. It's going to be the same as algebra 2. So
Let me get a homework log.
You want a homework log?
Actually, never mind. You're cool. I'm
You
doing
can
it.
give me that.
All right. Bye, guys. Have a great weekend.
Wait,
Is that right?
Yes, that is the assignment.
okay, but I also
The 53 through 59